It's a while since I've taken something dodgy, electrically powered and pink to bits, so it seemed appropriate that while I was browsing through some local Asian shops, I noticed they had one of these. Now, what brand is it? Oh, I should have noted what brand it was. I'm not 100% sure about that. However, it's an LED nightlight, and it's in the characteristic lurid pink. So let's pop it open and see what the circuitry's like. Let's change the screwdriver bit. That'd be a really good idea to one that's actually going to open it. There it is. So it works quite well. It just lights up cold white at night and turns on quite decisively. It doesn't really do that sort of dimming up thing that many of the others do, which is interesting. I wonder if that's reflected in the circuitry inside. Ooh, blimey. Rightio. Oh, the photosensor goes through a little grommet designed to block some of the light. That may be why it does the more decisive turn on. That circuitry is complex in relative terms. There's the rectifier, there's the dropper capacitor, and instead of just using a single transistor to turn on, it's using two. I think this merits further investigation and reverse engineering. I shall be back in a moment. So I've thoroughly reverse engineered this now, and it's quite an interesting circuit because it's actually very complex compared to the cheap ones. It starts off with a mains derived power supply using the standard capacitive dropper arrangement, whereby it's got a 100 nanofarad 400 volt capacitor in the series of the mains, and that lets a small portion of current through in each half wave of the mains. That's got a 360k resistor across it, this tiny little one, this slightly undersized one, which makes sure that when you unplug it, it doesn't hold a charge across that capacitor, give you a tingle across the pins. It's got a 470 ohm resistor here as an inrush current limiter, which is used in this case because there's no smoothing capacitor, but it's always a good idea to add these. And what that means is that if you get the sine wave, if you turn it on midway in that sine wave, then this capacitor is going to instantly charge to that sort of peak voltage, so to speak, and it's going to let through a significant pulse of current that could damage these LEDs or the circuitry. So that limits the current to, in our case, with 240 volts, it limits it to roughly an RMS value of about half an amp. So then you've got the full wave bridge rectifier, which is based around these four diodes, which converts the AC to DC. And this is where there's a difference, because with the cheapy units, they wouldn't have much circuitry. They might have a smoothing capacitor, but quite often they'd have the LEDs, they'd have a transistor shunting the LEDs, and a light-dependent resistor turning that transistor on, so that when it was bright, that transistor would basically turn on and turn the LEDs off, although technically speaking it would be drawing slightly more current at that point in time than when it was on. But having said that, they're quite low power anyway. And the main advantage of that is it means they can use a cheap low voltage transistor, and it just requires the light sensitive resistor and a little resistor here to just make sure that it turns that transistor off when it's dark. And this one has completely different circuitry. This one starts by deriving a low voltage supply from the mains, from the rectified mains supply and limited by this 360k resistor limiting current through this Zener diode, which is rated for 12 volts. And a Zener diode, when it's reverse biased like this, turns on at its rated voltage, and that limits it to that level. So that means this capacitor, which is rated for 47 microfarad and 16 volts, that will then charge up to about 12 volts and provide a fairly stable 12 volt supply. And that is then used through a resistive divider, this resistor here and the light sensitive resistor, to turn this transistor here on. And when that means that when these transistors turn on, now there's two of them because the high voltage transistors tend to be less sensitive than the low voltage ones. They tend to have a lower gain. And by using what's called a Darlington pair, where one transistor, its gain is effectively multiplied by the second one, it basically, you end up with a much higher gain single transistor by combining the two, but you end up with a slight voltage drop across it. But in this case, that's not that critical. What they're doing here, though, is they're amplifying the light-sensitive resistor arrangement here to turn on these transistors, and when that happens, the LEDs then turn on. And when it's bright enough during the day, then this light-sensitive resistor conducts enough to pull the gate, the base, should I say, of this transistor down low, and that turns them off and the LEDs go off. And there is an oddity, a 150k resistor across the LEDs. I'm guessing that's just to sharpen the transition between on and off. Not sure about that. I'm guessing that is to ensure that any slight leakage at the lower current levels gets shunted out quite decisively, because LEDs will glow to a very low level. It doesn't take much current to make them glow slightly, and that's probably what that's for. So it's very complicated, certainly compared to the other circuit, which just has the light sensitive resistor, a pull down resistor, and then the low voltage, cheap low voltage transistor across LEDs. This one is a lot more complicated. And I will also say that this one had an oddity. I came in today, and this has been plugged in overnight in the crew room, just on the table, and it was lit today. That's a bit odd. I'm not sure why it was lit today, but it hadn't gone out in daylight, and when I put my hand over the light sensor and removed it, then it went out. So it's a wee bit quirky. Maybe ultimately, although this is technically speaking the better design, maybe the simpler, cheaper design is actually better in the long run. But yeah, other than that, it's just quite a nicely constructed light. It's pretty typical. It's not got any major glaring technical problems. Other than that slight one of latch on, which is, to be fair, quite a technical problem. It's notable, I mentioned this probably at the beginning of the video, that it's got this grommet over it that when this is assembled and then you push this grommet over the LDR, the light dependent resistor, it forms a sort of light seal to a degree, which stops the side illumination of the LDR by the LEDs themselves, so that probably makes it more decisive when it's switching on at night. But yes, it's quite a nice little unit.